Welcome to the third session of Unit 3 that is called as acceptance sampling. In the subject that is called as the statistical quality control. So once again, after the completion of the course, the students will be understanding the basic concepts of the acceptance sampling. So in the last session, that is what in the previous session, we have discussed something about the operating characteristics curve, and we have studied how the operating characteristics can be constructed. As I've told you in the last session, the operating characteristics can be constructed by means of taking the sample, which is some fixed percentage of the lot. Say, example, if there is 100 items are there in the lot, 10% of the 100, it is 10. So 10 is the sample size. If you go to the second sample, say in the second sample, say lot is 1000, 10% of 1000, say it is 100. Now the sample size is 100. So here, irrespective of the size of the lot, we can fix some percentage, and as I've told you that the percentage will be from 0 to 10 or up to 20, you can go for that. So by means of that, we can construct the OC curve. And there is another method. We can construct the OC curve by means of the fixed n. N is constant irrespective of the size of the lot. So with which, we can construct the OC curve. And then we have studied something about the risks of the producers and something about the risk of the consumers. And apart from that, some of the definitions that we have studied, AQL, that is called as the acceptable quality level, LTPD, that is called as the lot tolerances percentage defective, and AOQ, AOQL, all these things, we have studied in the last session. So now, in this session, we will be studying, as I told you that in the first session, I have told you that there are varieties of the sampling plans. And in these varieties, we are supposed to study only the single sampling plan and the double sampling plan, multiple sampling plan, and the sequential sampling plans. Apart from that, there are so many types of the sampling plans are there. Subject point of view, we are supposed to study these 4 types of the acceptance sampling plans. So now you can see here a flow diagram. A flow diagram has been given here. This flow diagram represents the acceptance sampling procedure. Okay, so now in the what exactly it will happen in the single sampling plan, as the name indicates that there will be only one sample will be drawn. You can see you can go through the flow chart here. Randomize a sample of size n from the lot n. So we have to take a sample, okay, of size small n, and from the lot that is capital N. Say for example, here n is equals to say 100. N is equals to say 100. That is capital N is equals to say 100. And small n will be, it is depends upon the consumer and the agreement between the consumer and the producer. So consumer may say n is equals to say 5. So what does it mean? It means that first we have to take randomly a sample of 5 items from a lot of 100 items. So that is the flow chart. It is, first step in the single sampling plan is that we have to take randomly a sample of articles or the jobs from small n, and from a lot of capital N. Lot means the lot of the capital N we have to take. Then whatever the size that you take, whatever the size that you take, you can see here the second block. You can see the second block. Whatever the size you take, that is a sample. So inspect all the items in the sample. Say there are 5 items in the sample, you have to inspect all the 5 items in the sample. So once if you inspect all the samples of all the all the items of that sample, then you have to identify. You have to identify how many are the defective. Say for example, n is 5. How small n is? The sample size is 5. And in that 5, say you have obtained, say, two defective items. So then d value of the d will be 2. Now, after that, we have to compare this d. That is, d is called as the number of defective. And we have to compare this d with the c, that is called as the acceptance number. So this acceptance number, it comes to the final stage where with because of the the understanding between the producer and the customer. So they will decide it here, whatever may be the value. Say 5 is there, 5 is the sample size. Say d is equal to, say for example, 2. Okay, so then c is equal to, say, 2. So now D is 2, C is also 2. What does it mean? So D, number of defectives, are equals to the acceptance number. So what does it mean? So it means that if the value of the defectives, if the total number of the defectives of the sample is less than or equals to C, so then yes, if it is less than or equal to C, yes, you have to accept the lot. If this value of D is more than C, so then no, reject the lot. So you have to reject the lot. So once if you reject the lot, so then do the 100% inspection. You have to go for the 100% inspection. When you go for, after rejecting the lot, when you go for the 100% inspection, so here we can reduce the producer's risk and return to the supplier. So you have to return it to the supplier. So that is, this flow charts indicates the 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 single sampling plan. The same single sampling plan you can now summarize in terms of the wordings. That is a single sampling plan. What exactly is the single sampling plan? Say first, as I have told you, draw a single sample from a lot with draw a single sample from the lot, and the acceptance and rejections of this lot is based on the number of defectives in the sample. It is decided by the mutual understanding between the producers and the customer. So depending upon the mutual understanding between the customer and the producer, so they will come to a conclusion that is called as the C. C is nothing but the acceptance sampling. So here we have to draw a single sample. That's why it is called a single acceptance sampling plan. So single sampling plan. So we are drawing only one sample, and that depending upon the defectives that is present in that sample. So, the lots will be either accepted or it will be rejected. So it's rejections of the lot or the acceptance of the lot. It totally depends upon the defects that is present in the sample. So decision to accept the lot or reject the lot on the evidence only one sample. So this decision of the accepting or rejecting of the lot, it is depends upon only one sample. That's why it is called as single acceptance sampling plan. So the acceptance plan is also known as the single sampling plan. Usually, this is the type of inspection. With this type of the inspection, there will be always an agreement between the producers and the customer. So this agreement will take place because to find or to decide the acceptance number, that is called as C small c. Then the lot accepted by sampling will be accepted by the customer, and defective units will be the defective units of the samples will be replaced by the good one. Rejected lot will be returned to the customer. Rejected lots will be returned to the producer. So this is what it is called as the single sampling plan. Now, this single sampling plan notations. What are the notations for this single sampling plan? So now, this single sampling plan. In this single sampling plan, so capital N, it represents the number of the pieces that will be there in a given lot. N, small n, is the number of the pieces that has been selected randomly from or drawn, randomly selected or it has been drawn from the lot. And C is the acceptance number. So this C is the acceptance number that will come because of the agreement between the customers and the producers. It is the maximum allowable number of the defectives in a sample size n. So maximum value will be the acceptance number. So for designing a single sampling plan, numerical values of capital N, small n, and C are to be agreed upon the customers and the producers. So deciding the plan, so these three factors, that is capital N, lot size, small n, size of the sample, and C, the acceptance number. So these are the three factors so that will shape out the single sampling plan. Now, for example, you take an example here. So if capital N, as I told you, capital N, so that is the lot size, 100, and small n is the sample size. Out of 100, we are supposed to pick, we are supposed to draw, we are supposed to randomly we are supposed to pick 6 items out of the 100 items. So this is a single sampling plan. That's why out of 100 items, we are selecting 6 items, and C is equals to 0 here. So this C indicates that the consumer here saying that if in this lot, if all the 6 items are good, he is going to accept the lot, or otherwise I can say that C is equals to 0 indicates that the consumer will say that if that lot contains 0 or less than 0 defective, then only he is going to accept the lot. So that is the meaning of that capital N, small n, and the C. So this means that, I will just go through that. This means that from a lot containing 100 units, a random sample of 6 units is drawn. This sample of 6 units is subjected to proper inspection. If the number of the defectives in the sample is more than 0, the lot will be rejected. Otherwise, it will be accepted. So it means that, in this plan, there should not be a single defect. There should be a 0 defect. If the 0 defect is there, only the lot will be accepted. Otherwise, the lot will be rejected. So now, what are the good requirements, or I can say that what are the requirements to say that the single sampling plan, it is a good sampling plan? We can say that we should know the OC curve. First of all, you should know OC curve well. If the OC curve is proper, then I can say that it is one of the requirements of a good sampling plan. So the first requirement of a good sampling plan is that OC curve is, it should be known. The second requisite, or the second characteristics, I can say that the producer and the customer should be protected from the risk. That is the second requisite of a good sampling plan. If you design, whenever we have designed a single sampling plan, that single sampling plan should protect, or I can say that any sampling plan, it should protect both the customer as well as the as well as the consumer. So both the parties should be protected here. If that is done, so then we can say that it is one of the requirements of a good sampling plan, or one of the characteristics of a good sampling plan. And the third characteristics, or the requisites, or the requirements, is that the plan should be minimized. The whatever the plan you make, whatever the plan you design, it should minimize the cost of inspections for all the lots. So you design the single sampling plan, or you design the sampling plan, any sampling plan, but it should minimize the total cost of the inspection. So that is the third requirements of a good sampling plan. Next, the fourth sampling plan, sorry, the fourth point in the fourth requirements, or the characteristics of a good sampling plan, is that the plan should be flexible to reflect the changes in the lot size. So as I've told you that these plans will be made with the, we can change the lot size, we can change the sample size. So there is a flexibility here. So there is, whenever you go for the drawing the OC curve, okay, so OC curve, so there is a flexibility, or the OC curve for the single sampling plan or double sampling plan. So there will be a flexibility, because there is a change in the capital N, that is the lot size. There is a change in the sample size N. So there is the quality of the product is submitted. So there should be a flexibility in that. So that is the one of the requirement of a good sampling plan. So measurements received by the plan should provide the information, usually in estimating individual quality lot, and also along run over quality. So here, whatever the measurements that you will receive, you should provide the information. There should be a proper information. If there is a proper information on the outgoing quality of the product, so then we can say that it is a good plan, or I can say that it is the requirements of a good sampling plan. So the next one is the properties. What are the properties? What it should have? So the properties of quality, sorry, operating characteristics curve. The acceptance number C, the sample size N, are the most important factors in defining the OC curve. As I've told you that OC curve in the previous unit, as I've told you that OC curve will can be defined by means of the four factors. One is the capital N, that is the lot size, and the small n, that is the sample size, acceptance number, producer's risk, and the customer's risk. The producer's risk and the customer's risk will be appeared after drawing the OC curve. But before drawing the OC curve, so, or I can say that the factors which defining the OC curves are nothing but capital N, small n, and the acceptance number. So decreasing the acceptance number is preferred. Say the value of C here, the value of C, if the value of the C increases, okay, so preferred here over increasing the sample size. That's what. If the acceptance number, if it is reduces, so there will be a quality. If the acceptance number increases, we are getting the less quality products for the consumers. So that's what the second property of the OC curve. The third property, the larger the sample size, the steeper is the curve. The curve that is we are going to obtain as the number of the size, as the number of the sample, if it increases, the OC curve will become steep. It will not be, you know, like a curve. If the sample size is reduced, so then you are going to get the OC curve that I've shown you in the last class. So these are the properties of the operating characteristics curves. So the next, how we can construct the OC curve, that is the operating characteristics curve. So we can construct the operating characteristics by means of the two factors. That is, one is called as the probability of acceptance, okay, and the probability of the number of the defectives. So these are the two things, that we are taking considerations for the constructions of the OC curve. One will be for the vertical axis, and one will be on the horizontal axis. So there are three distributions. Basically, we can determine, we can find, or we can construct the operating characteristics curve by means of the three theories, I can say. So that first theory is called as the hypergeometric theory. So with the help of the hypergeometric theory, we can construct the OC curve. We can also construct the OC curve by means of the binomial theorem, and we can also construct the OC curve by means of the Poisson's distribution. So these are the three distributions, okay, with which we can construct the operating characteristics curve, or it is called as OC curve. So with the help of these three things, we can construct it, and we will be learning this hypergeometric, binomial, and Poisson's distributions. So in future, so when we go further, so you will be studying this one. So that is the one way of construction of the operating characteristics curve. So now here, so to construct among the three distributions, the Poisson's distribution is most important for the easy way can construct for the calculations. So Grant describes this hypergeometric and binomial distribution. Poisson's describes this approximations for the acceptance sampling. So here here the first one is it can be calculated, or we can say that the OC curve can be constructed by means of the Poisson's distribution. So the Poisson's distribution function is applied to the acceptance sampling is as PR is equals to e to the power of minus NP into NP to the power of R divided by R factorial, where PR is the probability of exactly probability of, I can say that PR is the probability of getting R defective in a sample of N, in a sample of N samples, that is N, that is nothing but N is called as the small n is called as the sample size, and P is called as the fraction defective. So there are three distributions. As we know that there are three distributions. One is called as the hypergeometric distribution, one is called as the binomial distribution, and one more is called as the Poisson's distributions. Out of these three, the Poisson's distribution is is used where we can calculate very easily. So we can find the probability of the accepting PR can be found out by means of the formula that is called as e to the power of minus NP into NP to the power of R divided by R factorial. So this is the formula with which we can determine or we can find, or we can draw the OC curve. So now we'll go for some of the problems here. So now a single sampling plan uses a sample size of 15 and an acceptance number 1. Using hypergeometric probabilities, compute the probability of acceptance of 50 articles which is having 2% defective. So here there are the given the data is that there are in a lot there are 50 articles. In a lot there are 50 articles, and out of the 50 articles, 15 items has been selected. That is the small n. That is small n is called as the sample size, and there is an agreement between the customer and the producer stating that the acceptance number 1 C is equals to 1, and the while submitting the lot, the producer says that there may be the 2% of the defective. So the P is equals to 2%. So 2% means P is equals to 0.02. So now here we can find so the number of defectives. Okay, there are 2% of defectives will be there. Out of 50, the customer, the producers is saying that out of 50, there may be the 2% of the defective. So it means that it is 0 point. Okay, so 0 point. It is actually it should be 0.02. Okay, so it has been wrongly written here as 0.002, but it should be 0.02 into 50. When you do, you will get 1. So what does it mean? Out of the 50 article, the producer is saying now here, producer, according to the producer, he is saying that out of the 50 article, there may be 1 defective. Then we can find out the number of non-defective. So here also word has been missed here. Number of non-defective articles it is. It should be number of non-defective articles. So the number of non-defective articles, the last sentence I am reading, once again you see here, wrongly it has been typed here. It should be number of non-defective articles. Now the total number of the articles is 50. Producer is saying that there may be a one job may be defective. So we can say that the non-defective items or the good one will be equals to say 49. Say there are 49 items, they are good. So now we'll solve this problem. So now what is the probability of getting the acceptance is what? So the number it is I can say that the number of non-defective articles, okay, divided by the number of the number for the lot, or I can say that simply I can say that it is NCR by NCR. When if I say that NCR by NCR, so what does it means? So it means that NCR for the defective non-defective articles, NCR for the non-defective articles, and divided by NCR. So NCR means here it is for the lot. Okay, when you take the numerator NCR, so where the value for that N in the numerator stands for the non-defective articles. Out of 50, there is a 1 defective item. So N stands for N will be equals to 49, and R then N will be equals to 49, and C will be it is equals to the sample size, because we have taken 15 number of the samples for the inspection. Then when you go to the denominator, once again it is NCR. Now this is NCR. It stands for the whole lot. In the whole lot, how many items are there? There are 50 items. So in the numerator, say this, I'm just indicating here. See here in this numerator, this N stands for the 50 article, but R it stands for the 15. That is the sample size. So that's what so what we can do is we have to see here the value of C is 1. So the value of the C is 1. So what does it mean? The value of the C is 1 means that if there are 0 defective, the customer is going to accept the lot. Even if there is a 1 defective, the customer is going to accept the lot. So it means that we have to find out the probability of getting 0 defective. Then we have to find out the probability of getting 1 defective. Then you have to add both those things. When you add both those things, you'll get the probability of the acceptance. Here, the probability of getting 0 defective, when you put this value in the numerator, it is 49 into 15, and in the denominator, it is 50 into 15. When you take the calculator, in the calculator NCR is there. So when you press that NCR, before pressing the NCR, you have to type the value of N, then NCR, then put the value of R, you are going to get the answer. So when you get the answer, for the non-defective items, and you get the NCR for the whole lot. So when you divide both those things, when you divide both these things, you are going to get, say, this is equals to 0.7. So now I'm getting 0.7 is the ability of getting 0 acceptance. Now, similarly, you need to find out the probability of getting the 1 acceptance. Once again, NCR by NCR. So this is for the defective, non-defective items. This is for the whole lot. So the whole lot will remain same, but for the 1, so 1 here, the R will change. So in the previous case, we have taken R is equals to 15. R is equals to 15. Now R is equals to 15 we have taken. Here we should take R is equals to 1, because we have taken what is the probability of getting 1 probability of getting 1 acceptance. So that is when you put, so you'll get here, I'm getting 0.3. Now if I add 0.7 plus 0.3, I am getting to get this one. So I can say that, so this is the probability. 1 is the probability for this sampling plan. So for this sampling plan, where n is equals to, capital N is equals to 50, small n is equals to 15, and C is equals to 1, and the probability, probably this lot may contain the 2% of the defective, which is P is equals to 0.02. So then we are getting the probability of the acceptance is equals to 1. So this is how we can solve the problem. So I'll go to the next problem here. Next problem, you can see here. Once again, in a single sampling plan, uses a sample size of 15. Once again, the values are same, and the acceptance number is 1. Now we have to solve this one by means of the Poisson's distribution. Compute the probability of acceptance of 50 articles with 2% of the defective. It is the same problem, where capital N is equals to 50, small n is equals to 15, C is equals to 1, and P is the 2%, that is nothing but 0.02. Now we have to calculate here the NP. So because we are using the Poisson's approximation, so whenever there is a Poisson's approximation, we need to find out NP. So NP is equals to N, sample size it is 15, into 0.02, so it is equals to 0.3. Now using the Poisson's approximation table G, okay, for the P1, so getting the 1 defective, okay, so or less, I can say that, okay, getting 1 defective or less than 1 defective. So from the table, from the G table, when you go to the statistical tables, at the end you will get the G tables, so grand tables. So that in that table, we will get this getting the probability of, okay, probability of the acceptance, okay, probability of acceptance for NP is equals to 0.3 and C is equals to 1. So we will get it as 0.963. So this value is 0.963 we will get from the table. So now how we will get this one from the table? In the table or at the top, so the numbers will be given 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is the top most of the table is the value of C, and vertically downwards you will get the values of NP. So for NP is equals to 0.3 and C is equals to 1. So you will get the value which is equals to 0.963, or or we can find out the same thing by means of some the formulas. See here we got 0.963. It is from the table. Okay, for the values of NP is equals to, for the values of NP is equals to 0.3, and for the value of C from the G table we got 0.0963. So same thing, we can find out it by means of the formula. So here PR is equals to e to the power of minus NP into NP to the power of R divided by R factorial. So now we got the value of NP is equals to 0.3. You can see here it is equals to 0.3. So NP is equals to 0.3. So PR is the formula, that is the Poisson's distribution formula. It is equals to e to the power of minus NP into NP to the power of R divided by R factorial. When R is equals to 0, when R is equals to 0, then we can write e to the power of minus 0.3 into 0.3 to the power of 0 divided by 0 factorial. When you calculate, you are going to get the probability of getting 0 defective. It is equals to 0.7408. Similarly, we can find out probability of getting 1 defective. So PR, R is equals to 1. When you substitute this value, R is equals to 1 and NP is equals to 0.3. So in this formula here, we are going to get the value probability of getting 1 defective. It is equals to 0.2222. So then what is the overall probability? That's what the probability of acceptance is equals to probability of getting 0 defectives plus the probability of getting 1 defective. When you add these things, you are going to get the value. It is 0.963. It is 0.963, which is matching with the value that we have obtained from the Poisson's approximation table. You can see here we have got, before the calculations, we got the value of probability of getting the 1 acceptance. It is 0.96 with the table. Now we are getting the same value 0.963 from the by means of the calculation. So that's how we can calculate the probability of getting the acceptance. So here I have completed the third session. Okay, so thank you very much.